There we go.
Yeah.
What is this, Lady Ada?
Hey, everybody, and welcome to Show and Tell. This is our weekly show we do every Wednesday at 7:30 p.m. As always, I am Lady Ada. With me is Mr. Lady Ada. We're hanging out at the Ada Food Factory. It's all quiet right now because everyone's at home resting. The machines are asleep. But we're awake and we're ready to see what you're up to. Makers, hackers, and creators around the internet, come by and show us your project. We're here till 7:50. And we have some Ada Food peeps and we have some visitors. But everyone is welcome, and we have some space still. So let's kick it off with JP.
Hello, I have a cardboard hand here that I'm very excited about that I wanted to show you. So I'm working with Cricut for the first time. I've gotten my early Cricut board in. I've been playing around with it a little bit. And so for tomorrow's live stream, I'm going to be building or rebuilding or improving a version of this hand and maybe taking it a little further. But as you can see here, I've got four standard servo motors connected up. I've got a nice big power supply to make everything run nicely. And my Circuit Playground Express that is plugged into my Cricut here is allowing me to use the capacitive touch pads. I've got 4 touch pads on the Cricut to trigger the servos and pull these fingers. So let me pull that up a little closer and you can see. So that is my my progress so far with this cardboard-based rubber band, straw, and string hand. And I've tried a bunch of different versions of it. I've played around with some different materials and some different configurations. So tomorrow I'll share what I've learned about some things that I think make this work pretty well for an animatronic cardboard hand made on the cheap.
All right. Okay. Thanks, JP. Nice. Gotta hand it to you.
Hello, Katney.
Katney, what's up with you?
Hey. So I spent the last week at PyCon, where we sponsored by giving away gemmas, and so I revamped Sophie's amazing badge that she was kind enough to send me to work with the gemma. And I've written up a guide that shows how to do this. Basically, the way that this works is there's 3 different touchpads on gemma, and each of them does something different. So this one changes the mode. Hold on. All right, so this one changes the mode, which changes colors, sends it to some blinky modes, and sends it to a rainbow mode. It's yellow and blue for Python colors.
Yay.
This one here changes brightness.
Oh.
As you can see, it gets a little bit brighter there. And this one changes speed. So if you want some real fast blinky action, you can get that set up.
Yay!
So there's another project on that same guide that allows you to affect each art red, green, and blue with each different touchpad, so you can make your own colors if you want to. And those are both available. The guide is called Gemma Light Touch. So check it out.
Sweet. Thanks, Katney.
Right. Be playing some of the videos and adventures from PyCon tonight on Ask an Engineer.
Yeah, it was very fun, popular.
Thank you for doing that. A lot of people had a lot of fun.
Yeah, absolutely.
All right, now Pedro.
Hey guys, what's up, guys? So this week we have a Circuit Python or Circuit Playground Express powered drone claw. So what it's going on here is we're using the light sensor on the Circuit Playground Express to sense when the LEDs on the Mavic DJI Mavic Pro drone turns on here. So we have a PETT filament, which has these optical properties. It's pretty much like fiber optics. So when it senses the LEDs turned on here, it just sends it into this light-proof case that we designed. So if anything else, you can still use this case to make like a light sensing case for your Circuit Playground Express. And this works in direct sunlight. So we just mapped the LEDs to the custom control there. You can see the claw goes on and on. And the Mavic Pro is pretty tough. It can, fly in the rain. You can crash into a tree and the props are just fine. And it can hold about 2 pounds. So if I just put that on there and close it, you have a nice little latch drone on there. You can totally customize the claws to this. You can mount like a different attachment on there. You can just let it go. Drop. So one of the cool things you can use this for is for, especially right now, like in Hawaii, there's a bunch of like eruptions and volcanoes. You can do like, if scientists are out there, they want to send like samples to, research teams that are like in a different area. You don't have to like, be all dangerous and climb through things, or especially with like hurricane season coming up, you can maybe get like some, first aid supplies around or something like that. So lots of cool educational things you could do with a flying claw. In the video that we released this week, we showed like beach cleanup. So everything was coded in with MateCode. So it's actually my first MateCode project. I was able to just stumble around and just throw blocks around until I was able to do what I wanted to. So we have links and, of course, all the designs and the whole step-by-step tutorial on learn.diddyfruit.com. So definitely check that out. And, of course, on 3D Hangouts today, we talked for a whole hour on all the design considerations on designing this. So definitely check that out.
Sweet.
Okay.
Got hands and claws, all sorts of appendages.
Next.
Okay, let's check in.
Chris. Hey, Chris.
Hey, Chris, welcome
Can
back.
you hear me?
Yes.
Okay. Well, a little bit over a week ago, I released my infrared library to run on the Metro M4. And that was a big milestone. There's some significant differences between the M0 and the M4, and I had to figure those out. Thanks to you with helping me debug some of it, and got a lot of help from Scott and some people at AVS Forum, at Atmel AVS Forum, helped me out with it as well. So we got that uploaded. I was going to report last week, but I had laryngitis, and I didn't feel like doing maker charades. So anyway, I'm going to do a screen share here. Wake up, click minimize. Mouse 312 666 66. Click. Mouse 152 8888. Click. Go to sleep. Okay, you see a Fusion 360 screen here?
Yeah.
Okay, I'm working on a new project that's going to have a feather wing and board, M0 BLE, and a TFT display. And I wanted to model the case in Fusion 360. And of course, Noah and Pedro have got models up for most of your boards and accessories. But I wanted to modify this one. First of all, I like to put image maps on my devices. They look nicer than just a plain device. Also, I wanted this one to have the pinholes in it. Their original model for a feather board did not have pinholes. So I've added pinholes, I've colored the components, and I've added an image map. Then here's a sort of a generic, just a plain wing board. I put the holes in it so that I could later modify it. And then here is a board that I'm going to use that they did not have modeled, which is the non-latching relay feather wing. And so I created that model with the pinholes and the hole for the signal pin and, double row of holes like it has, and the little reset switch. Then I need to model some pins. I wanted to see how the pins were going to line up, and you did not have any models for pins. So there's a standard set of feather pins. Also got some stacking feather pins. By the way, I know that you have low profile headers, but have you ever considered doing low profile stacking headers? Or is that even possible?
Yeah, we actually went down this path of getting quotes for it, basically because it's a non-standard pin. It's like really, really expensive because we have to like custom mold the metal pinning and like it at the time when I started it, I was like, I don't know, because the feather had just started, but I might go back and try again and see, okay, now that feather's popular, maybe we can get the custom header made.
Yeah. Okay. Also needed a little barrel jack, so I made a model of that. And then this is the project that I'm working on. It's going to have the 2.2 inch or 2.4 inch TFT display wing. And again, Noah and Pedro already had one of those, but it did not have the pinholes in it. So I added that and added an image map. And then I'll show you how all this stacks up if I can click on the little light bulbs here. Hang on. We're going to add an M0 BLE.
Oh, yeah.
Ooh.
This looks great.
Add some pins. Oops, wait a minute. Kind of hard to hit these little things. There's the pins.
Ooh.
Static and header pins.
That's nice.
Here's the relay board.
Yep.
with the pins, and then add a LiPo battery. And now I haven't finished yet, but this is sort of a start of what the enclosure is going to look like.
Looks
That's
nice.
cool.
So anyway, by putting it all together, it would help me visualize what kind of enclosure that I really needed, and design it that way. And I've got holes for all the jacks, and they've all lined up just right. So I'll come back sometime when the project's finished and tell you what it's supposed to do.
Okay.
I just wanted to show off these parts. I put all of those custom parts that I've modeled onto GitHub, and along with, of course, my new infrared library update for the M4. So all of that is on github.com/Slyborg5.
All right. Thank
All
you so much,
right.
Chris.
Epic.
Okay, next up, JMK. Hello, JMK.
Hey, welcome back, JMK.
Hello. Hello.
Hello.
Hello. What you got this week?
So, first of all, I wanted to say that JamQOS has a new update. We've been working on it for a while. It's called the Mist update. It's in beta right now, and we've added class support. So, what it means is each thing that's in the operating system, each tool is split up into separate files. So basically, now instead of one file called input.jmk that contains everything, you have the core.py or core.jmk file. Then you've got the color and text library, and then you've got some other stuff, and apps can add functionality using that too. Also, I made this thing with that simulates like a little world, like with me and I put like me and my brother in this little world thing. Here's what it should look like. This is what it starts with. You can see it says finish initialization. Then it has the details of each person, begins the world. Then it has pictures of each person. I coded this. I forgot to say that. Yeah. The world creates, then you can select the carrier you want to perform operations on. Seems there's something weird going on here. This window won't close, so I think you can just come back to me because this window won't close, so I'm just going to close that.
All right, we'll step back in a bit.
Come back later.
Okay, next up, we're gonna go to Techniac.
Hey, Techniac. Welcome back.
What's up?
Hello, everybody. Can you hear me?
Yes.
All right, one sec. I'm not getting feedback. So I actually, about 5 minutes before this started, I got a package from you, and I got another laser cutter. So
Right.
yeah, I'm addicted.
Good to have.
And we checked out from my library a couple days ago a Circuit Playground. So I'm working on a project right now because we have a concert coming up soon. So I thought it would be cool to make a sound reactive pocket square. So I got some NeoPixels,
Mm-hmm.
and the idea is I'm going to connect them and then use the microphone on the Circuit Playground to interface with it and sync them to the music and the speakers. So I have that, and another small thing I've been working on actually. I screen share quickly. Please don't crash. I've added a option on my website to be able to submit the custom settings for materials from Home Depot for the Glowforge, because I've been trying to cut some wood and stuff, and it's just so much trial and error. So I figured once one person gets it, you can upload it here, and then everybody can use it.
Cool. If you email me at PT at Adafruit, I'll do a blog post.
Oh yeah,
So-
great.
Yeah, we'll
and then-
crowdsource this.
Yeah,
thing.
here's our quick link for it. And then this is all on Wix, and this is actually my first time working with a large-scale database. So
Oh, cool. You know, we'll in the title of the post, I'll add Home Depot. Like, it would be in their best interest to help out with this. I'm sure they're.
yeah, that'd be great. I have some bugs to work out with it, but I'll send you an email once it's all set.
Yeah, it might get used a lot. So.
Yeah, I figured.
Get it solid.
Yeah.
So there is a test cut image. So the idea is you download that so everybody's running the same
Yeah.
cut. So we can control the settings on that.
Okay. Yeah, we'll let Glowforge know too. Maybe they can help get the word
Yeah,
out.
I was going to say, I'll shoot an email over to them.
Okay.
So
All
that's
right.
it
Good stuff.
for me this week.
Okay. Next up. Oh, if you want to stick or email supported it.
Yeah.
All right. Next up. In at 6.
Sean.
Yeah, Sean.
Hey guys, how you doing? I started this project a while ago and I'm planning on open sourcing it. But the idea is that I believe that we can intelligently monitor and analyze the Earth's resources so that we can determine the true carrying capacity of the Earth in order to create like this dynamic equilibrium without environmental neglect. So I've been working on like a few proofs of concepts. I'm on my second, working on my third, which is deployed. But this one here is just a simple temperature sensor. It was the first proof of concept. It's just a Raspberry Pi, and it's communicating with MQTT. And I had a few roadblocks with the technology. 4G. First start with 4G, that didn't work in the remote areas. Monitoring water, starting there. When I deployed the first buoy in the watershed, it couldn't get a signal, and I tried Iridium, and then so what's really cool about it is I'm broadcasting over ham radio. So what's happening is if all infrastructure collapses, you could at least know where the fresh water sources are in your local area. So right now, as you can hear from my ham radio, those are signals coming in from the buoy and from this temperature sensor, which is broadcasting from this little radio here. I have it receiving radio in my Radio Shack that's taking that signal and posting it to AWS Dynamo and Elasticsearch and Wolfram Alpha. So you can Databin, so you can actually run like analytics against it. And my goal is to get the buoys open source and all the technology open source, and eventually, once I get it all cleaned up, and be able to monitor water, air, soil, stuff like that.
I feel like this is a cutscene in one of those movies where the world's about to end and they need to find the person who can help out.
And they're like, get Sean.
I feel like there's going to be an I told you so moment later, but thanks for keeping on this. I'll send you a sticker. It feels like I should send you more, but thanks for keeping an eye on things.
Everything was purchased from you guys, so thank you. I'm not much of a electronics guy. I'm more of a software infrastructure, hardware architect as a day job. So this was like, trial and error, but I couldn't have done it without you guys and without Learn. So thank you very much.
You did a great job. Nice
All
work.
right.
I hope you learned something too.
Yeah.
All right. We'll need you in 25 years.
Yeah.
So keep working on it. In 25 years, you're going to save the Earth.
I don't know if we have that much time.
Okay. 5 years.
All right. Next
Okay.
up.
Ranjib.
Ranjib.
Hello.
Hey.
This is Ranjib. I want to show one of my project. It's a pet project. It started almost 2.5 years before. These are my reef tanks.
Oh, nice.
Ooh, nice tank.
This is one of the hardest and kind of expensive hobby to do because of many things we have to maintain. And a lot of a controller can help a lot. Commercial controllers cost a lot. And 3 years before, I was learning electronics from Adafruit, so I slowly started building things. What you see in the background is a couple of it's a modular system. So it comes. The ReefPi project talks about these circuits, which is basically a Raspberry Pi and an ancillary set of say Adafruit breakout board like PCA9685, temperature DS18B0 probes. What it allows you, and this is an Atlas Scientific pH probe. What it allows is to automate all the 6 or 8 key functions that is essential for reef keeping, and you do it entirely with open source software and hardware as a DIY project over the time. And this is a all-in-one controller.
Oh, neat.
I'm not sure if it is visible.
Yeah, because with reef stuff, there's so many different parts of the water and the temperature. There's like, it's absolutely everything.
Yeah, so you can at basic you can control equipments like when you are doing water change or anything, you can stop things like the water movement, heater, skimmer, and all those things. The second step is that temperature failure or heater failure is one of the major reasons for reef tank failure, and each of these reef tanks are like 5 to 40 years old. It is like people's really passionate about it. So to prevent that, you can set up a basic temperature controller with DS18B0. This one does that. The third thing it does is that it automatically senses the water level and pour water as evaporation happens. That keeps the salinity at a check, and that is also important. So this is the basic 4 thing, and finally we control the daylight cycle using the PCA 96850 things, and we reuse everything that is already in the industry, that is the the lighting and all those things. We just hook up the controller and you can use as you want. This is a 2-year project. First 2 year was the basics things. This year we have now we have like a 40 plus people who are working on this thing, building and contributing code, and we have now feature like pH and peristaltic pump doser control, which allows you to keep some of the hard to keep corals.
Yeah.
These are great.
This is absolutely beautiful. Thank you for sharing this project. If you send a PT at Adafruit, that's my email address, a link when you're ready to talk about it, or if there's a website.
Absolutely. No, we this is our working time in West Coast, so I never really get to attend this. I wanted to be here for almost 2 years, and I've been to Maker Faire. But yeah, this was a great opportunity.
Fantastic work, and I think raising awareness on the reefs in general, because they've been around forever, but it is fragile. We don't get to keep these forever.
Yeah.
Thanks so much. I'll send you email support at Adafruit. We'll send you a sticker too, of course, right for the front of the
Those
sticker.
are gorgeous reef tanks.
Okay, we're gonna go to Dannon, and then we'll check back with JMK if
Okay, Dannon.
audio video.
Hey.
All right, Dannon, take it away. You got 2 minutes. No pressure.
No
Let's see.
audio.
No audio. You want to do Maker Charades? Yeah, do Maker Charades. Okay. First word.
Okay, so this is that robot,
Yeah.
the kit with all the robot parts in
You
it.
got a bunch of stuff in there. Got it.
Not the Anki bot. I don't remember the name of it.
Yeah, that
But
was
it's like it's a 3D printed like charging station.
Yeah.
Okay, 3D printed charging station.
All right. Lady just like TensorFlow over here. She can just recognize.
Yeah, that's
it.
way better than the one that it comes with. I don't remember the name of this. What is it, Osmobot or something? I think is it
Someone will type it in the
Osbot?
chat.
I don't remember.
Someone will type it in the chat. Oh yeah,
Cosmo.
Yeah,
I
yeah.
was close.
All right. So you got the Cosmobot. You made your own custom charger. It's better than the
Cosmo.
original. And then this is
Like a headset.
yeah.
The battery
That goes on your
pack.
head.
It definitely goes on your head.
Oh no, it
Maybe it's
goes
bone conducting.
open air speakers or microphones.
Some ear thing.
Yeah,
I don't
okay.
know, some headset thing. Okay. But there's like a battery. It's either a battery or a bone conductor. Like, well, what is it though? I don't know.
Yeah. Let's see. Looks like that comes out.
Oh, it's a USB battery pack.
Oh, those are battery packs.
Yeah, it's a USB
Yeah,
battery
got it.
pack. So headset, USB.
Maybe Bluetooth.
Maybe for like long term. He wants to like not have to.
Yeah. And that's
Well,
that was a
that's
little
something.
that was a little controller thing.
Oh, it's
Now
gone, forever.
Yeah,
I'll
you'll
never-
never find it again. All right. Is that your project?
That's pretty cool.
All right. Thank you so much.
That's good stuff. It's
Yeah.
battery week here at Dannon's house.
All right. And we're going to check in with JMK and then we're going to wrap it up because we got to do show.
Okay, JMK.
What you got?
Okay, so here's what it should look like. So once you finish the initialization, I call it, of like, I have 2 people, it's me and my brother in this like virtual world thing. You select the character you want to like perform as. I'll select myself, and there's like, what I'm doing is I'm gonna make it so there's like a list of things that it prints ASCII basically, but you can see a list of like ASCII text. Like let's go to the backyard, and then what it does is I'm gonna have it so there's like in ASCII for like all sorts of things. I found in like a website that has like 1,000 like ASCII images of everything. So what I'm gonna do is I'm gonna make it so you can select a person and then say like person is doing whatever it's doing. So that it's like a virtual world. And then also that I
Oh,
I think he. Oh no, we lost JMK.
he closed the wrong window.
I think he went. I think
He went into the virtual
I think
world.
he transported to the universe.
Okay, wait, you're back. And now we
Oh,
can't hear you.
You're back, but we can't hear you.
Unmute yourself.
Oh, okay.
back.
Okay.
Something weird happened there. But anyway, the eyes kit that I called in to win I think it was 3 weeks ago. It
Yeah.
just came today. So yeah, that's gonna be fun. I can't wait.
Okay.
All right, awesome.
That's
All
it for
right.
now, yeah.
Okay.
Yay!
I hope the universe that you make with all the things is a nice, kind universe.
It definitely will be. especially with my brother. He'll just be in the basement all the time.
All right. Okay. Well, that's the show and tell this week,
Okay,
everybody.
Thank you,
Take care.
Techniac,
Take care.
Ranjib and his fish, Noe, Pedro, Katney, JP, JMK. Int 16 is radios,
Sean,
Danon, and Chris Young.
We're every single week. Thank you for making it the best half an hour. Ask an Engineer starts at 8 p.m. And of course, we are here next week, 7:30 p.m. Eastern Time.
See you next week.
Bye-bye, everybody.
And in 4 minutes.
Yep.
Bye, everybody. I'm gonna get a chocolate snack.